Hi, everybody, and welcome to lecture 5.3. So this will be the lecture for week 6, but it will be in conjunction with what we did in week 5 because we're sticking with the host immune system. So with that, I'll go to the PowerPoint. And for 5.3, the learning objectives I have for this particular lecture are that you should still be able to name the branches, or excuse me, you should be able to name the branches of the adaptive immunity. So this is the third line of defense, and be able to compare this adaptive immunity to the innate immunity that we covered in mini lecture 5.2. In addition, you'll be able to compare and contrast two of the white blood cells that are of particular interest in the adaptive immunity, which are the T and B cells. And even within the T cells, I'd like you to be able to compare and contrast the T helper cells and the cytotoxic T cells. So with that, I want to go to the whiteboard and just remind you kind of where we are and in regards to what we covered last time. So when we look at the whiteboard, let me make sure that it's going there. We were talking about, oops, let me find a better color than that. So we had been talking about the host immune response. And I drew it kind of as a concept map, so I'm going to continue with that. And last lecture, what we were talking about was the innate immunity. And we broke that into two parts. We had started out with the first line of defense, which was those barrier defenses. And so hopefully you remember we talked about chemical, physical, and mechanical defenses that we might have. So mechanical, maybe tears washing something away, physical being something like maybe our skin. And then we could talk about the chemical things like the hydrochloric acid in our stomach. So hopefully that helps you kind of keep in mind what we talked about with that first line of defense. The second line of defense, then we were talking about cellular, which was the phagocytosis. And then we were talking about molecular. And that was things like cytokines, so interferon. It was also the complement cascade, and it included fever and inflammation. And that would have been the second line of defense. So we could say this is the first line, this is the second line. And the one thing that we said about the innate, or the kind of things to keep in mind about it, was that it was non-specific. So it didn't matter if you were being infected by the measles or by the common cold, our innate immune system would react similarly or the same. And it also had no memory, meaning that just because you've been exposed to something once doesn't mean that your body will respond any differently in a subsequent exposure. So that kind of covers what we've already talked about in the last lecture. If you need to, you can always go back and look at it. But now we really want to talk about the third line of defense, and that is what we call the adaptive immunity. And remember, we can think about the innate as something you're born with. Your adaptive immunity basically develops over your whole lifetime. And we can divide this into two groupings. We have one group that is called the humoral. We'll talk about that a little bit more in depth. And this would be our B cells that would be part of this, and also our antibodies. So antibodies that our body can produce. The second part of this is what we call the cellular, and sometimes you'll hear it referred to as the cell mediated. So don't be surprised, that's kind of what we can also hear it as. So cellular or cell mediated. And this one really has to do with our T cells. So we really, last week, we covered kind of all of this part, or last lecture. But today I'm really going to be then covering the part then over here of the adaptive. And we're going to talk about it, kind of introduce the two parts, and then talk about how the humoral and the cellular help our body fight off an infection. Let's go back then to the PowerPoint. So as part of this, what I want to talk about is that adaptive immunity. And one of the things that we want to think about this is that this is a little bit different if we compare it to the innate immunity, in that it is very specific. So the responses will change depending on the pathogen that the host is confronted with. So the common cold would get a different response than perhaps if you were infected with the measles or if you were infected with the coronavirus. So we want to think about it as being specific to a specific pathogen that the host is exposed to. And you also want to always keep in mind that our adaptive immune response requires more time than our innate to begin to kick in. So you might get fever or inflammation or phagocytosis almost immediately with exposure. With the adaptive immunity, it will take days to even weeks before your body can effectively clear a virus from it. And as I said, we have two branches of it. We have both the humoral and the cellular responses. And these are used to neutralize, meaning stop it from really spreading, and then control and eliminate viruses. And we'll talk about how it does that. The other part of the adaptive immunity, besides the specificity, the ability to identify a specific pathogen, is this idea of memory. And this is where I always say, I'm a Taurus. That's my sign, and I am somebody who holds a grudge. I think of the adaptive immunity as having a grudge. And that's because the adaptive portion of your immune system can exhibit memory, which means that if you were infected with, say, chickenpox as a child, your body will remember, so that if you're exposed to chickenpox maybe 5 years down the road, you will actually have a much stronger and more rapid response to that than the first time. And so we talk often about the fact that a secondary exposure to that same antigen, so chickenpox in my example, you would have a much more rapid and effective immune response, and often not even know that you were exposed that second time because you would have that immunity. And we'll talk a little bit more as we move through in future weeks that we actually use this knowledge of the adaptive immunity in order to make vaccines. We do vaccines, so we trick the body into thinking maybe it's seen a pathogen, so that when you actually do see it, you get that secondary response. And that's kind of how vaccines work, but we'll get into that in more detail. So as I said, the adaptive response can be divided into two branches. I talked about the humoral response, which has those B cells and can make these antibodies to a particular antigen. And then we have the cellular response, which the T cells would play a role in. The key thing to think about is both of these would be going on at the same time, and they have the same goal. The goal is always to eliminate an antigen that has been identified and then remember it so that if you see it again, you can respond more quickly. So this kind of gives you an idea time-wise of what we think of if we were to look at our innate immunity, which is non-specific, versus our adaptive, which is specific. So if we look across the x-axis, we have days after an infection. And then up on this side, we have the amount of interferon or virus that we might find in the blood to show us kind of the level of how much virus we have in the body. And what we would typically see is you might have exposure then on day 0, and you can see we get this huge increase in probably the first couple of days, first 2 to 3 days of the virus that is replicating in the body. And what the body does is we have this innate response in that about day 2 to 3, interferon starts to kick in, our non-specific defenses, which would include natural killer cells, but also fever, inflammation, phagocytosis, all those things would begin to kick in on like day 3. That will begin to kind of taper off right around a week to just after a week. And this is our non-specific, our innate immunity doing this. Now, if that virus is still kind of sticking around, we would expect then that our adaptive immunity would also respond. But generally, we don't see it start to respond until about day 7. So about a week after we were exposed to the virus. And really, it hits its peak kind of at about 2 to 3 or 4 weeks away. And so you can see there's definitely this delay from that innate immunity to our adaptive immunity. So let's talk about what are the big players, who is involved in this response. And as I said, there are 2 types of cells. We have what we call our B cells or T cells. They're both considered lymphocytes, so we find them in our lymph tissue. And they're just white blood cells that make up part of our adaptive immunity. These lymphocytes will hang out, if you will, in the lymph nodes. So we have lymph nodes kind of at the base of our neck, under our armpits, and in the groin area. And basically, this is where they hang out, looking for any kind of infection that they need to respond to. Both B and T cells are made in the bone marrow, but they mature in different places and they become different cells. So B cells will actually mature in the bone marrow and then move into those lymph nodes. T cells will actually be made in the bone marrow, but they will mature in the thymus gland and then move into the lymph nodes as well. And so what we want to talk about first is what happens on the B cell or the humoral side. And so what I have is kind of a simple drawing from your book. We have the virus particles up here. They have these antigens, things that stick out on them. You want to think about the spike proteins that are a particular shape. And the nice thing about our adaptive immunity is that we should have B and T cells that have the ability to recognize any antigen. And so what basically happens is these viruses, the B cells kind of check and see, do I have a match for that antigen? If they have a match, and this is showing it basically bonding, it activates the B cell. It tells the B cell, hey, you have something that you've recognized. It's a foreign intruder and we need to get rid of it. And so what will happen is that that activated B cell will go through cell division and make a bunch of clones, make a bunch of B cells that can recognize the same virus. What happens then is we will tuck some of those away for a memory B cell. So in case you ever encounter this virus in like 5 years from now, you'll have a memory of it. But really, the really important thing that we make are these what are called plasma cells. And these plasma cells will make antibodies. You can see they show these kind of as these little stick figures, but these antibodies have the ability to bind on to wherever the virus is in the body and bring attention to it so it gets phagocytized and destroyed. So the antibodies would be specific, would be specific to the virus that started this whole process. So if this was the measles virus, a particular B cell would recognize it. When it recognizes it, would become activated. It would go through cell division to make lots of copies that can all recognize that virus. And then it would send out all these antibodies to go attack that virus. But remember, it's always tucking away a memory cell as well, so that if you get exposed to it in the future, you will recognize it faster. So when we think about that, as I said, we have this different response by the secondary or second time we see an antibody, or excuse me, an antigen. So again, if we go back here and we kind of think about the days along the bottom, and this though now we're looking at the amount of antibody that we might see that's being produced by a host. We get exposure. We start seeing maybe at a week. Some antibodies are being made, but really at about 2 weeks is where we peak out, and then we're over it within about 4 weeks. If we were to see that same antigen that was back here a second time, let's say that it's 5 years down the road, what we expect to see is that in a much shorter period of time, we will start to see antibodies and we will make way more antibodies sooner, which means that we will clear it out often before you even know you were exposed to it. So this would be like the first time you catch measles, and this would be the second time you're exposed to it, you likely wouldn't even get sick or have symptoms. So hopefully that explains why we kind of think about that as so important that it has a memory for a specific antigen. And remember, we can mimic this with a vaccine by pretending that that vaccine is the primary antibody response, so that when you're exposed to it really the first time, it looks like a second time to your body. And we'll talk more about that in a few weeks. So that's kind of the B cells and how the humoral side works. With the T cells, or the cellular or T cell mediated immunity, we know that these are slightly different. So with the B cells and T cells, they recognize the viral structures a little bit differently. I kind of showed that the B cell could recognize that whole virus particle with its spike proteins on the outside of it. T cells are a little bit what I would call more picky, and they can't recognize as much. So they can recognize, though, these foreign antigens. Sometimes it will be an already infected tumor cell, and sometimes it will be that it's been presented to them from phagocytosis. So I think I mentioned in that video on phagocytosis that after they destroy the virus, they might hold some of it up to show the rest of the immune system. And that's where our helper T cells would come in. So the two big groupings of T cells that I want you to know about are the cytotoxic T cells and the helper T cells. And I'm going to go back and just kind of give you a quick analogy to think about all of these cells and keep these in mind as we move forward. So if we go back to my whiteboard, one of the things that I'd like to point out here is that if we kind of think about this, I think I've said that I think of it as kind of this war that our body is fighting. That means that we can think of phagocytes that we talked about in the innate immunity. Phagocytes, I often like to think about as the scouts, if you will. They're basically on guard duty and looking for anything foreign coming into the body. With the B cells, they can send out those antibodies that will specifically target a given antigen or a virus. And so I refer to these guys as the sharpshooters or snipers, if you will. When we get to T cells, the interesting thing are there are two kinds of T cells. One is the helper T cells, and I like to think of these guys as the generals. They don't really fight the virus, but they coordinate and order around all the other cells like phagocytes, B cells, and cytotoxic T cells. The other type of T cell is what we call a cytotoxic T cell. And this one you can think of as really the one that will go in and destroy viruses or virally infected cells. So I think of this as our foot soldier. So it's kind of the one that gets in and fights. Hopefully that helps you. And as I finish up this lecture, I'll continue to kind of use these terms, but we can think about all of these working together to help your body fight off a viral infection. Okay. So we'll go back to the PowerPoint and we'll walk through these. So as I said, those two populations of T cells would be our cytotoxic T cells that we often shorten to that T with that subscript of a C, and then our helper T cells, which were the generals, which is the T with a subscript H. So the way that this works is I'm kind of showing two different things at the same time. On the left-hand side of this is a new helper T cell that is being presented by some phagocyte, a piece of a virus. This actually activates this helper T cell. When it becomes activated, it goes through cell division and makes clones. And we have lots of this helper T cells then that are made that are going to be the general. They're going to run the whole immune response and order around all the other cells. But remember, we have a memory in the adaptive as well. So we would put some helper T cells as memory cells that will allow us to remember this particular virus. On the other half, on the right-hand side then, if you will, of this picture, I have a cytotoxic T cell. This one also has to be presented by a phagocyte, a piece of that antigen. And when it's presented with that, it will activate, again, the cytotoxic T cell. That activation then allows it to go through cell division, make lots of copies because we need a lot of kind of foot soldiers to fight this. Again, it will tuck away a memory cell as well for if you run into this one again. But then what these cytotoxic T cells or foot soldiers do is they travel to where the infection is. They find the cell that is actually infected with the virus, and they basically put out these chemicals. The first chemical causes the infected cell to get a bunch of holes in it. And then they put across an enzyme that will actually cause that cell that's already infected, that host cell, to go through cell death. So go through apoptosis and destroy it. So as I said, they're really the foot soldiers. They're coming in and they're destroying those infected cells. So with that, I want you to kind of think about what's going on. We have, and I'll go back to the whiteboard probably just to kind of think about that. Again, we can think about it starting with kind of the innate immunity when we first have some sort of virus in the body, and we would expect to see our phagocytes recognize it, they'd chew it up, and maybe put part of it out to show the rest of the body. B cells might run into some of the virus on their own and become activated and start sending out antibodies, shooting them out at the viruses. And then we had our T cells, which again, these ones are the ones that we would have our helper T cells would have seen it on a phagocyte that has been put out for them and would become activated and start coordinating the whole immune response. And our cytotoxic T cells or foot soldiers, when they see that piece being presented to them on a phagocyte, they then will go through cell division and form an army to go attack any cells that have been infected by the virus. So hopefully that's kind of a nice tie-up for that. We'll go back then and finish up on our PowerPoint. As I said, the helper T cells do not get in and fight. And again, that kind of follows that idea of them being the generals. They don't get in and do the hand-to-hand combat, but they are the ones that order around or support and coordinate the response. And they do that by activating B cells, activating cytotoxic T cells. They then will get the innate immunity, so the phagocytes to begin to proliferate, and they might even increase the inflammation and or activate inflammation and fever. So let's finish up with the checking in. This is a good point to pause the video and go ahead and write down your answers or say them out loud, and then you can come back and I will go through the answers. So for the first question, what are the two branches of the adaptive immunity? The two branches are the humoral and the cellular or cell-mediated branches. Which response is associated with T cells? That is the cellular branch. And the one that is associated with B cells is the humoral. The second question is, what are the two key characteristics of adaptive immunity? That would be memory and specificity. So the specificity to a given pathogen or virus and memory of it so that the secondary exposure, you have a faster immune response. Question 3, once activated, what do B cells ultimately produce? B cells ultimately produce antibodies. Remember, they're the sharpshooter, so they can shoot out these antibodies that are specific for that pathogen to attack it and get rid of it from the body. Question 4 is, what is the function of an activated cytotoxic T cell? The cytotoxic T cells are our foot soldiers, so their function is to go to infected cells and destroy them. What is the function of an activated helper T cell? Helper T cells, their job is to be the general, so to coordinate and activate or mobilize the rest of the innate and adaptive immunity to clear the body of a virus. If you have any questions, please let me know. I do have a lot of videos posted. Some of it may go into more detail than I've done in the lectures. So expect that the questions on the next exam or quizzes would be from my lectures, not necessarily completely from a video. Thank you.